if we think about the direction of the ship and how it relates to the force, we can understand why we chose cosine instead of any other trig function. So let's first start here. Let's first understand that we have theta in our code, and anytime you see theta, the universal symbol is just a circle or an O, or better get a circle with a line through it, okay? So let's draw our ship, and let's say we want our ship to go, I don't know, up in that direction, up and a little bit to the right and a little bit up. So let's draw our ship this way. Okay, so we want the ship to kind of go in that direction. And so let's draw an arrow pointing the way in which we want the ship to go. So that's a nice little arrow. I'm not the best artist in the world, but I think that's good enough. So we want the ship to go in this direction. So we can call this arrow, I don't know, we can call it F of thrust. And we do have a F thrust in our code. And we have theta. So let's draw theta in here. So let's draw, I don't know, that with theta. So this is what we got, okay? So we want the ship to go in that direction, and we have an angle, theta, and it's starting to look a little bit similar to, I don't know, triangles, in particular right triangles. So let's finish the picture. Draw a triangle, and let's draw a right triangle. So we want the ship to go a little bit to the right and a little bit up. And one thing we know about triangles is that we have trig functions. And let's remind ourselves what each trig function is. And there's a little name for it. Do you know it?
All right. Awesome. Yeah. And also, before I go on to talk about SOHCAHTOA, though, I think one more thing we need to add is the f of x part of it. Or the f and the subscript x, I mean.
Oh.
Yeah,
so
I gotta.
If we want to go a little bit to the right, we can call this particular side of the triangle, I don't know, let's give it a little nickname. Nothing special, just call it f of x, I don't know. And if we might as well just finish off, so we have our f thrust as our hypotenuse, our f of x as our bottom side of the triangle, our adjacent side of the triangle, and this opposite side of the triangle from the theta, we can call it f of y. Just giving each side of the triangle a name so we can work with it a little bit more. So let's go back to what we were about, the trig functions.
Yeah, so here we have the, SOHCAHTOA, of course.
Absolutely.
Sure everyone in high school knows, or, you may have heard of it. If not, you'll definitely want to know about it. So we go SOHCAHTOA, and basically, it tells us, this is supposed to be sine, cosine, tangent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So, for going, we want the adjacent side, right? We want fx, the adjacent side, and the one that has the adjacent side in it is cosine. So see, cosine here is adjacent over hypotenuse.
Right.
So there we go.
So let's take that trig function and let's plug in our values of adjacent and hypotenuse, and let's see if we can do a little bit algebra to get a particular value for f of x. So let's go cosine of theta. Okay, and we got our adjacent on top. So our adjacent in this particular scenario is f of x. So we can our adjacent side of the triangle is f of x. So let's put f of x on top. Our hypotenuse is f of thrust. So let's put that. And if we multiply f thrust over, and if we switch the sides, we can get this particular equation. And all I'm doing here is just multiplying f of thrust, okay? And this is just a little small multiplication. So right here, we have a particular equation, we move to the side, of f of x. And from force of law, our number one favorite equation is F equal ma. And if we, second number one equation is, our second equation is a of x equal f of x over m. So we plug in our value for f of x and plug that in. And this is our line of code. We got our auxiliary x, which is equal to our f of f thrust times our cosine of theta divided by m, which is our mass. We learned that back in Force to Blob. So we do the same thing for fy. So what particular sign are, a little bit of a teaser right there. Go ahead.
Yeah, definitely. I'm glad you asked. So what we want to do now is think about, okay, so we want fy. Well, that's the opposite here. Opposite. It looks like maybe we might need sine for this because there's opposite right there. So we'll do sine here as, opposite over hypotenuse. Right. And so that should help us out here.
So let's do the same procedure as we did with cosine or with our f of x. Let's do the same thing with f of y. So let's take sine of theta and plug in our values. So our opposite is f of y over our f of thrust. And so we multiply over, we get an f of y. And now we have our value for f of y, and let's do the same thing to get our ay, which will give us over m. So from here, we now understand why we chose cosine of theta, and we also understand why we need our sine of theta for our y, for our f of y. And also we understand that accelerate y is equal to f of thrust times sine of theta divided by our mass. So let's jump back to the editor and see if we can get this ship to move in the y direction now.